Now, we establish this. We have a problem involving rates. You know what the definition is of an average rate. You can always apply it. Maybe it doesn't work, maybe it doesn't help, but if there's a rate of change involved, probably it does, okay? And you want to consider it. Am I making sense? Okay, hard to get yourself in the habit of doing that. Okay, so if you know alpha and delta t, you can find delta omega, right? If you also know the previous value of omega, you can find the new value. If you know omega and you know how much omega changes, how do you take the value of omega and the change in omega to get the new value? If you weigh 130 pounds and your weight changes by 5 pounds, how do you figure out what your new weight is?
You subtract it by the old weight?
Well, what would it be? If you weigh 130 pounds and your weight changes by 5 pounds, what's your weight going to be?
5 pounds more.
5 pounds less.
Well, when I say changes by 5 pounds, I wasn't specific about that being a displacement versus a distance, right?
Yeah.
So if I wasn't specific about it, if I want to be really specific, I'll say if your weight changes by plus 5 pounds or by minus 5 pounds. So 135, 125 would be valid answers unless the context or the statement specifies which way it goes, right?
Yeah.
And again, that's distinction between distance and displacement, okay? Something you want to keep in mind because it will keep popping up, okay? Maybe not next week, maybe not even next year, but sometime, and probably next year. Okay, so that's easy, right?
Mm-hmm.
And actually, that's pretty darn easy if you've got a rule for calculating alpha, right?
Yep.
And we do. So you calculate alpha, you multiply it by delta t, there's your delta omega, and you add it to your old omega, and you got your new omega. Okay? So, next question. What if you know theta and omega? Complete my sentence for me. I'm afraid I might be running out of space on my card, so I'm going to go erase some stuff.